Now sir, next concept is linear programming. Linear programming problems. Okay, what is meant by a linear programming problem, sir? For introducing this chapter, let us see. Suppose there is a manufacturing concern or any firm you consider. For any firm, sir, material is the resource, manpower is the resource, that is availability of man hours, availability of machine hours. Using these resources, how can we produce or how can we find out the best solution to the given problem? Okay, the objective of any firm is to maximize the profit or minimize the cost. So, under the given conditions, how to give a mathematical model to the given problem, how to find the solution to the given question. This is what linear programming stands for. Basically, it is utilization of resources, which is similar to that of your marginal costing techniques. Marginal costing techniques are short-term decision-making techniques, whereas LPP is coming for long-term decision-making techniques. Look at the definition. Linear programming deals with the optimization of maximization or minimization. Linear programming deals with optimization of a function of variables, of a function of variables known as objective function. Subject to a linear equations inequations. Okay, look at the definition one more time. Linear programming deals with optimization of a function of variables known as objective function. So for every linear programming problem, there is an objective function which is profit maximization or a cost minimization, subjected to certain inequalities, that is subjected to a linear equations or inequalities known as constraints. Constraints means restrictions you are imposing, sir. Here we are assuming as such there is no firm or industry with unlimited resources. When limited resources are there, how to use these resources to find out the best solution to the given problem, either to maximize the profit or minimize the cost. Okay. So this linear programming we are solving under the headings of formulation, solution by graphic method, and primal dual concept. Simplex method is deleted from our syllabus, sir. In the new version of the study material, simplex method problems are deleted. So who have old edition, that is 2013 editions, they have simplex method. But those who have 2014 September or December edition, we don't have any simplex method problems. Okay. In which page it is given? Page number 2.303. Page number 2.308. Page number 2.308. This is the linear programming. Okay, first understand what is meant by linear programming, then we will discuss various concepts for this linear programming. To explain what is linear programming, how a problem is given under this one, look at the example number 1. Example number 1, page number 2.309. Page number 2.309, example number 1. Example number 1. What is given, sir? A firm is engaged in producing. A firm is engaged in producing two products, A and B. Each unit of product A requires 2 kilograms of raw material and 4 labor hours for processing, whereas each unit of product B requires 3 kilograms of raw material and 3 hours of labor of the same type. Every week, the firm has an availability of 60 kilograms of raw material and 96 labor hours. 1 unit of product A sold yields rupees 40 and 1 unit of product B sold gives rupees 35 as profit. Formulate this problem as linear programming to determine how many units of each of the product should be produced per week, so that the firm can earn the maximum profit. Okay, this is the problem. Every one of you open the study material, page number 2.309. Go through the question, sir. There may be a difference of page numbers in the old version and new version. So, I have a new version with me. So, my page number is 2.309, sir. Those who are having old version, take up your respective pages. Now, step number 1. Step number 1, formulation. Look at the question, sir. What are the restrictions imposed in the given question? Availability of raw material. Only 60 kilograms of raw material is available per week and 96 labor hours are available. Using these resources, how many units of product A and how many units of product B the firm has to produce in order to maximize its profit? This is the question. So, for this, decision variables are product A, product B. You have to decide how many units of product A and how many units of product B the firm has to produce in order to maximize its profit. So, objective function is profit maximization. Okay. For this maximization, what information is given? Every unit we are selling will give 40 rupees as profit from product A, 35 rupees as profit from product B. So, objective function for the given problem is maximization. What are the resources available, sir? Resources available are raw material, labor hours. Restrictions are always imposed on resources only. Okay. With this, how to give a mathematical model to the given problem. Let us say the question is equal to x1. Number of units of product A, number of units of number of units of product A the firm is deciding to produce per week. X2 is equal to number of units of product B. X1 is equal to, sir, number of units of product A, and X2 is equal to number of units of product B. Next, second point is X1 comma X2 are greater than or equal to 0. X1 comma X2 are greater than or equal to 0. It means they will take only positive values. Third one. Objective function. Maximize Z. Z is a variable, sir. It has no significance. Just you take profit P. No problem. Maximize profit. So you write maximize P or maximize Z. Maximize profit is equal to profit contribution from 1 unit of product A into number of units plus profit contribution from 1 unit of product B into number of units. So, profit contribution from 1 unit of product A is 40 rupees into X1 plus 35 rupees is the profit contribution from 1 unit of product B into X2. This is objective function, maximize profit. Maximize profit. Okay. Subject to how many inequalities we will get for the given problem, sir? 2 inequalities we will get. One for the raw material and one for the laborers. So raw material. Number of kilograms of raw material required to produce 1 unit of product A into number of units plus number of kilograms of raw material required to produce 1 unit of product B into number of units must be less than or equal to available quantity. Must be less than or equal to available quantity. Look at this one more time. Number of kilograms of raw material required to produce 1 unit of product A into number of units of product A, number of units of product A plus number of kilograms of raw material required to produce 1 unit of product B into number of units of product B. This must be less than or equal to available quantity. What is given in the question, sir? Each unit of product A requires 2 kilograms of raw material. 2 kilograms of raw material is required for 1 unit. How many units we decided to produce? X1 units. So 2 into X1 plus each unit of product B requires 3 kilograms of raw material. 3 into X2 must be less than or equal to 60. This is inequality 1. Second one is in terms of labor hours. Number of labor hours required to produce 1 unit of product A into number of units of product A plus number of labor hours required to produce 1 unit of product B into number of units of product B number of units of product B must be less than or equal to available hours. Must be less than or equal to available hours. Each unit of product A requires 4 labor hours for processing. Look at the question. Each unit of product A requires 4 labor hours. So 4 into x1 plus each unit of product B requires 3 labor hours. 3 into x2 less than or equal to 96. This is inequality 2. Okay, sir. So look at the problem one more time. What is the objective function? Maximize profit. This is equal to 40x1 plus 35x2 subject to 2x1 plus 3x2 less than or equal to 60. 4x1 plus 3x2 less than or equal to 96. x1 comma x2 must be greater than or equal to 0. Okay. Now, this one, let us compare with the definition, sir. Linear programming deals with the optimization of a function. So, optimization of maximization of profit or minimization of cost. What is the objective function? As far as this problem is concerned, profit maximization. So, the objective of this particular problem is to maximize the profit. Of function of variables known as objective function subject to linear equations or inequations or inequalities known as constraints. What is meant by constraint? Restrictions. We are imposing restrictions. Restrictions are imposed for resources only. What is given in the question? 60 kilograms of raw material is available, 96 labor hours are available. So, whatever may be the combination you are producing, they must be produced by using all the 60 kilograms of raw material and 96 labor hours, or less than 60 kilograms of 60 kilograms of raw material and 96 labor hours. Overutilization is not there. This way, when you give a mathematical model to the given problem, it is called formulation. This is called formulation. First step in linear programming. Okay, sir. You take up this one. I'll give you 2 minutes time. Then I'll solve the given problem by graphic method. Now, consider the problem one more time, sir. Maximize profit is equal to 40 into x1 plus 35 into x2 subject to 2x1 plus 3x2 is equal to 60, 4x1 plus 3x2 is equal to 96. This is the problem. Same problem I am considering. This is not end of the solution, sir. It is formulation only. In the exam, problem will be given and they will ask you to formulate only a 5 marks question. Formulation and graphic method may be a 10 marks question. So formulation is over. We are moving for solution by graphic method. Now, step 2. Solution by graphic method. For the sake of our convenience, inequalities are taken as equalities. 2x1 plus 3x2 is equal to 4x1 plus 3x2 is equal to 96. Okay, sir. One variable x1 we are representing on x-axis. Another variable x2 we are representing on y-axis. And we know one point. On x-axis, every y point is 0. And also on y-axis, every x point is 0. How to solve this? To get x1, put x2 is equal to 0 in 1. So 2x1 is equal to 60. x1 is equal to 30. Let us take this as point A. This 30, 0 is a solution to the given problem. 30, 0 is a solution to the given problem. What is the interpretation of this one, sir? Produce 30 units of product A, not even a single unit of product B. Produce 30 units of product A, not even a single unit of product B. This is one answer to the given problem. To get x2, put x1 is equal to 0 in 1, 3x2 is equal to 60, x2 is equal to 20. This is the point 20. This is another solution to the given problem, sir. What this solution is saying, you can produce 20 units of product B. Otherwise, produce only 20 units of product B, not even a single unit of product A. Okay. By solving line 1, we have two solutions. Similarly, we can solve line 2 also. Similarly, solving 2. When I take x2 as 0, 4x1 is equal to 96. By putting x2 is equal to 0 into x1 is equal to 24. This is 24, 0. Next, putting x1 is equal to 0 into 3x2 is equal to 96. x2 is equal to 32. This is point D. 0, 32. 0, 32. Okay, sir. So by solving the given two lines, we have 4 sets of points. Let us represent them on the graph. Maximum point on x-axis is 30. Maximum point on y-axis is 32. So 4, 8, 16, 20, 24, 28, 32. This is 4, 8, 12, 16, 18, 16, 20. This is 24, 28, 32. Okay, sir. Now, first point here is 30, 20. With these 2 points, I am drawing a line. On x-axis, let us consider a point 30. This is A. And on y-axis, it is 20. This is point B. Join these two, sir. Join these two. So this is 2x1 plus 3x2 less than or equal to 60. This is the line. Next, 24, 32. 24 is C, 32 is D. Draw one more line. This is 4x1 plus 3x2 less than or equal to 96. This is its point of intersection. This is point of intersection. After representing the lines on the graph, you have to identify the common area for the two lines, which is called solution set. Identify the common area. What is the inequality, sir? It is less than or equal to sign. Less than means below the line. The area which is common for the two lines and below the lines. Look at this. How many areas I have? 1, 2, 3. 3 areas we have. Suppose if I take a point here. This point lies below this particular line, but it lies above this line, which is not allowed here, sir, because your two inequalities are less than or equal to sign. Therefore, above the line is not allowed. Therefore, this part is not considered as a solution set. Next, consider this area. In this point lies below this line, but above the second one. So this is also not allowed, sir. Now, look at the lines with the blue pen. Any point in this area is a solution set to the given problem. Any point, because this is common for the two lines and satisfying the inequality sign. So shading this one, which is the solution set to the given problem. Shading. So this is called solution area. This is solution area to the given problem. Solution area to the given problem, which is called feasible area. Any point in this area is a solution to the given problem, sir. Any point in this area is a solution to the given problem. When the point is closer to the origin, resources are not utilized to their full capacity. As you are moving away from the origin, better and better utilization of resources. This point, one more time I am repeating, sir. In this area, I can consider any point which is a solution to the given problem. So, any student who is doing this chapter first time will get a doubt. Which points I have to consider in the solution area. So, if a point is closer to the origin, resources are not utilized to their full capacity. As you are moving away from the origin, better and better utilization of resources. So moving away from the origin, and on the line means 100% utilization of resources, sir. Therefore, consider all the corner points in the common area. Consider all the corner points in the common area. Consider all the corner points in the common area. So this is corner points. Profit is equal to 40 into x1 plus 35 into x2, profit in rupees. So what I am doing here, sir? The corner points coordinates I am substituting in the objective function. 40 into x1 plus 35 into x2, I want to convert into numerical numbers. What is the first corner points I am having? 0, 0, 0. Neither I am producing product A nor product B. So this is 40 into 0 plus 35 into 0. This is 0 plus 0, total profit is 0. There is no profit at all when the decision variables are not produced. Next point is C. This is 24, 0. This is point C, 24, 0. So 40 into 24 plus 35 into 0. 960 plus 0, 960. So total profit is 960, sir. Total profit is 960. There is one more point B, 0, 20, 0, 20. So this is 40 into 0 plus 35 into 20. 0 plus 700, 700. Finally, there is one more point E, whose coordinates are not known to us. Whose coordinates are not known to us. E lies at the intersection of line 1 and 2, sir. E lies at the intersection of lines 1 and 2. Solving 1 and 2. This is 2x1 plus 3x2 is equal to 60. 4x1 plus 3x2 is equal to 96. Minus 2x1 is equal to minus 36. x1 is equal to 18. So 18 units of product A. 2 into 18 plus 3 into x2 is equal to 60. What I am doing? 18, x1 value I am substituting in equation number 1. 36 plus 3x2 is equal to 60. 3x2 is 60 minus 36. 60 minus 36, 24. So x2 is equal to 8. x2 is equal to 8. This is working area, sir, working part. So now, how many points we have? 4 points. These are the 4 alternative solutions available. These are the 4 alternative solutions available to the given problem. First solution is 0, 0. Second solution is 24, 0. Third solution is 0, 20. Fourth solution is 18, 8. These are the 4 solutions. Now we have to select the best one. For that, let us calculate the profit at this point also. 40 into 18 plus 35 into 8. into 18 is equal to memory plus 35 into 8 is equal to memory plus MRC 1000 rupees. Since rupees 1000 is maximum profit, comma What is this? It is a firm. The firm has to produce 18 units of product A, comma 8 units of product B per week to maximize its profit. This is a complete solution to the given problem. That is example number 1, which is given in the page number 2.309. Page number 308, 309. Okay, sir. Now, note down the solution.